Now we look at example 1. Use the graph of fx is equals to modulus of x to find the graph of fx is equals to modulus of x minus 1 plus 2 by using transformation technique. So use the graph of fx is equals to modulus of x. So this will be our first graph. So where this is the basic function. So here is the basic function. So that's why you need to memorize the graph of basic function. So which is the V shape. So next, by using transformation technique, we will try to graph this function. So we have to do it separately. So means that first you need to know how to separate. First, our first graph is fx is equals to modulus of x. When come to the second graph, we will expand nearest to the x. So the second graph suppose is fx is equals to modulus of x minus 1. So from x, we try to expand one by one. So this is the first graph. Next, from x, we will expand to the whole function. So for the third graph or the final graph, fx is equals to modulus of x minus 1 plus 2. So we need to sketch three graphs. So let's say, now we look at, so the first graph, fx is equals to modulus of x. So this is a graph of basic function. So where you need to know this is in the form of V shape. So this is V shape, x, y. So this is the graph for y modulus of x. For the second graph, fx is equals to modulus of x minus 1 squared. So this is moved to the right for 1 unit. Again, how we going to know is moved to the right? So here is x minus 1. So I will let x minus 1 is equals to 0. X is equals to positive 1. So positive is right. On the same time, don't get confused with this graph. Fx is equals to modulus of x plus, not plus 1, but minus 1, let's say. So this is, don't get confused, modulus of x minus 1. Compare with fx is equal to modulus of x minus 1. This is x minus 1. This is moved to the right. Whereas for modulus of x minus 1, this is moved down. So you have to differentiate both of the function. So both our function are different. This is modulus of x minus 1, whereas this is modulus x minus 1. This is moved to the right, whereas this is moved downward. So the third graph, modulus of x minus 1 plus 2. So this graph, the whole graph will plus 2. Means that it will move up for 2 units. So this is the function that we're going to sketch. So the first graph, of course, is the basic function. So this is V shape, and this is at origin. So the coordinate is 0 and 0. So for the second graph, remember, it will move right for 1 unit. So I show you again, by letting x minus 1 is equals to 0, x is positive 1. So for this graph, from here, it will move to the right for 1 unit. So this will be the graph. So from the origin, now since move to the right, this point, so since this is moved to the right, sorry, right, okay. So from here 0. Before this is 0. Now move to the right for 1 unit, will become 1 and 0. And you need to find the y-intercept. So how are we going to find the y-intercept? So at y-axis against x is equals to 0. So substitute into this function, fx is equals to modulus of 0 minus 1, which is modulus of negative 1. Since modulus, this will become positive 1. So the y-intercept here is 1. Next, we move on the third graph, the final graph we need to sketch. Fx is equals to modulus of x minus 1 plus 2. So this one will move up for 2 units. So from this graph, it will move out for 2 units. So the whole graph will move out for 2 units. So you can see here, before this is 1, now move out for 2 units, 2 and 3. So the new y-intercept is 3. So therefore here is 3. Same as this point. It will move out for 2 units. 1 unit, 2 units. So this is the point. The x-coordinate is still the same, which is 1. But now from 0, because move up for 2 units, here will become 2. That's why this point is 1 and 2. So this is transformation of graph. So this technique is known as transformation technique. So the first graph, first it moves to the right for 2 units. This is a graph. And then the graph will move out for, first the graph is moved to right for 1 unit. Then it moves out for 2 units.